Let's look at Chapter 3.1, Whole Number Addition and Subtraction. We're going to start with if it were in class, a warm-up question here. 1, 2 plus 3 in base 5. What is that number? If you want to think about it quickly without converting, one method you would do potentially is kind of to count up from 3. That would be one way to kind of solve that. And thinking about, in my head, I'm thinking about 1, 2, right, is the same as 7. One group of 5 and 2 ones is 7, and then 8, 9, 10, right? That would be the numbers, but 10 is 2, 0, right? This would just be 1, 3, 1, 4, and instead of 1, 5, it becomes 2, 0. So that's one way to think about it. But we'll look at more strategies for adding mentally as we go on with this section. And then again, another discussion piece, again, more for a class situation, but it's important for you to think about this question here. And we'll look at some of that as we go through, and you can come back to what that answer would be, or something more, what, again, reasons for that as we go through addition. And so one thing we want to know about addition is that there are kind of two ways, right, to find the sum of two whole numbers. One is through what we call a set model, which is kind of looking to see how many are in each set and then putting the sets together. And another would be through a measurement model, which we'll talk about. So that leads us to kind of the definition. What does 3 plus 2 actually mean? Well, using a set model, we see 3 objects, 2 objects, join them together, right? Set A, set B, union them, put them together. You have 3 distinct objects here, 2 distinct here, and the total amount is now 5. And so looking at the definition, right, the sum of 2 numbers, we can look at sets. How many are in each set? Put those sets together. Now how many are in the union of that set? And so you can see from the definition of 4 plus 5, there's 4 objects, 5 objects. You put those together, and then how many objects are in the union of those 2 sets after you put them together, and that would be 9. So that's the idea of a set, right? You're joining 2 quantities together to get a new quantity. An important idea to think about is addition is what we call an operation. It works on 2 numbers. It's a binary operation. As you look at 4 plus 5, the answer to 4 plus 5 results in a new number. And notice you're working on this operator changes 4 and 5 into a single number, or 9. Multiplication is another example of a binary operation. But again, it's important to understand that this is an operation, like the orders of operation. This plus means do something to those 2 numbers and give me a new result. In this case, that's the sum. What would a measurement model look like? A measurement model goes back to the number line, right? Addition can be represented on a number line. And so noticing the sum here, 3 plus 4, you would go 3 and then 4 more. Where you end up is 7, and so that's using a measurement model and a number line, right, which is a measurement model is represented on a number line to find a sum. And then we have these properties for addition that you may be familiar with. Some people forget like what the words mean, and then they try to memorize. Important is just understanding that there are rules for these operations. Something happens, right? The sum of any 2 whole numbers is a whole number. That's called the closed property, right? It doesn't become something else. Remember, the addition is an operation, right? It's doing something on the numbers and then something happens. We have the commutative property, A plus B equals B plus A, right? Children learn that soon in their practice of addition, that it doesn't matter the order. They learn associative property, that you can mix and match the additions and it won't change the answer. If you have 3 numbers you're adding together, you will see that you can do A plus B first, or you can do B plus C first and then add A. And then there is a special number in whole numbers. It's called 0, and that 0 is is related to what we call the identity property for whole addition. There is a unique number 0 such that when you add any number with 0, the answer is always that number, right? Nothing gets added. And so those are important properties to be aware of. And then we have some practice problems we could look at real quick, looking at are these sets closed? Meaning that when I add numbers within, if I add 0 and 6 together, are my results always 0 or 6? So it's not closed in this case. It doesn't follow the closure property, right? The sum of two whole numbers is a whole number. In this case, our set is 0 and 6. If I put 6 and 6 together, get 12, it's not in the set, so the set is not closed. This set of multiples of 40 is closed. Looking at 0, 40, 80, 120, 160, any two numbers you add up will always be a multiple of 40. We could prove that, but I guess intuitively that makes sense. We would say this set is closed. Anytime you add a number from the set, it will be a number in the set. And then 6 is not closed either, because if I add 6 and 6 together, then it gets 12, it's out of the set. So it's not closed under addition. We'll look at other questions like closed under multiplication later. And then to finish this short video, which of the followings are equivalent to 2 plus 4? This is related to associative property. This one's good. I can break this up into 3 plus 1. This is equivalent here too, because once you have 3 plus 1, you can break it up or put it together. These are equivalent. 6 is not equal. This answer does not equal 6. Even though it equals a value of 6, it is 1, 5, and 1, 1 in base 5. So you got it. That's not the one that's equivalent, but the other ones are. You can rearrange, break this up, and then rearrange it.